Welcome to section 5.3. In this section, we're going to talk really about the solving of exponential and logarithmic equations. This is really the fun that we get to do after getting our base values and our understanding our rules that came about as part of section 5.2. To solve things, we're going to take advantage of properties 3, 4, and 5 the most of the things that we talked about. And 1, I suppose, also is a part of that as well. But all of these properties come into play, and that's why we're going to leave them on screen here so we always have a visual reference to those properties. All right, let's jump into example 1 on page 344. We're not going to worry about part B, but part A is definitely something we're going to attack. Solve the equation 3,000 equals 150 times 10 to the power of 4t. All right. So we want to figure out what t equals, and t is in the exponent. So how do we do this? Well, the first thing we have to do is we have to isolate the value that has the exponent by itself. So in other words, I want 10 to the 4t on the right side of the equal sign alone. I want it feeling lonely. I want it saying, I miss people, but I want it there by itself. All right, so the first thing we can do to take care of that is to divide both sides by 150. All right, so 3,000 divided by 150, that's going to be 20. So 20 is going to be equal to 10 to the 4t. All right, so now we made it. We made that 10t by itself, and so now we have to take advantage of our log rules to solve this. So what we're going to do is we're going to take advantage of the power rule to figure out what this t is. In other words, I want this t. In fact, I want 4t. I want it out of being a power. I want it being somewhere I can actually use it, because right now there's no operations that I know of that can solve for this other than using some trial and error, and I don't want to do that. So for me, I'm going to go ahead and take a log of both sides here. Now, why log? Well, because 10 is involved, I like using log. If 10 wasn't involved in the problem, what I would do is use a natural log, because I like the natural log myself. Doesn't really matter per se, but if e is involved, I have to use the ln. If 10's involved, it's just better for me to use log versus the ln. All right, by taking the log of both sides, and again, as long as I do it to both sides, it's legal. It's algebraically legal. Like everything else we've done this semester in algebra, as long as we do it to both sides, it's totally algebraically legal. And what that allows us to do then, let's put this over here, is to say that I have log of 20 on the left, and the right side of my equal sign is now 4t times the log of 10. We like that. Okay, that works. That 4t is now someplace we can use it. And by using log and not natural log, the log of 10, much like the ln of e, the log of 10 is 1. Let's put that over here. Another rule for us to remember is that log of 10 also equals 1. We'll add that to our properties here on the next go-round, but we'll put it there for right now. All right, what then this gives us then is that we have the log of 20 still here on the left, and now with our rule of log 10 equaling 1, we have 4t here on the right. So to solve for t, we're going to divide both sides by 4. And now we'll be able to solve for what t is equal to. Let me bring up a calculator I have on the computer so we can see this work together. Let's move it here so we can see what we're trying to do. And in this case, we're doing log of 20 divided by 4. So in this calculator, I can hit log. I can then put in 20. I can close parenthesis. And then I can say divided by 4. And it's going to give me the answer here that t is equal to 0.325. Let's transfer that back to our screen. 0.325. Again, I do like decimals provided we do it to 3 decimal points. And so 0.325 looks pretty good. For that, we can say that this answer is fairly relevant. Is this answer checkable? Yes, it's totally checkable. We could take 0.325, we could put it back into t over here. We could say we have 3 times 0.325. Take that then to the power of 10 and then multiply it by 150, and we would get 3,000. Just for grins, let's go ahead and do that anyway, since we already have the value on our calculator. So let's bring our calculator back into play here. And we'll say that, all right, if this is t, then if we multiply it times 4, so take our value times 4, and then make that a power to 10. So in other words, 10 to the power of this last answer we just had, and then multiply that times 150, and you'll see that the answer is indeed 3,000. So there's no reason to get these problems wrong. Yes, there's a few steps to take care of, but in the end, we can always check the answer to see if what's there matches